this is the Alpha. He is the core team member from the Hong Kong USD DevFest Student Cup core team. So the coming topic is in English and is also a machine learning topic. So let me pass to the Alpha then, and he will start his sharing session. And any comment feedback you can leave a comment in the YouTube. Thank you.
Thank you for the introduction. I'm Arthur, a second-year postgraduate student in UST. I am a research student, and my research is around human-computer interaction and reinforcement learning, that kind of thing. Today I'm going to talk about using the Tensorflow Hub. Start the slide. The topic is Tensorflow Hub introduction, and then it's models for everyone. Why Tensorflow Hub? Usually when we go to Twitter or we saw some latest research result from some Twitter post you saw in Twitter, and then you want to try on the model on your own, and then you go through some. You may go through the paper, and then you will try to search the name of the paper in GitHub, and then you find some code repository, and then you may search for more detail, and you may find the model code repository. Sometimes the between the model is right there. Sometimes it's stored on the cloud storage. Sometimes you may need to download for running servo script and to get access to the model. So as you may have many questions, how can I use the model? Is that safe? How was the training? What was the data? And am I using the model correctly? There are such kind of questions. There is Tensorflow Hub comes in to help developer and researcher have a more easy life. TF Hub is a place for listing Tensorflow model. Model listed in Tensorflow Hub with rich documentation, code snippet, and more. Here's the link of Tensorflow Hub. Tensorflow Hub have a rich range of amount of model, which offer a wide range of machine learning tasks for all of common ML needs. For instance, in image related, for example, in image related tasks, we have model for image classification, object detection, image augmentation, and also image generation. Also, for example, style transfer, face generation, or 3D model generation. For tests, we have state-of-the-art model like BERT or word sentence embedding kind of model. They also provide universal sentence encryptor and embedding for different language like Canton, Chinese, or other German language. It also supports a wide range of natural language understanding tasks such as question answering, like he just talked about it, and text classification, semantic analysis, and many more. They also have some video-related model which can help you to do video action recognition or pose estimation, gesture estimation, or even video generation. And recently, they also provide some audio model for things like pitch detection, sound classification, or music generation. I will go through the list of available model in the last section of the talk. And here is the TensorFlow ecosystem. You can mainly separate the two parts, yes, training and deployment. TensorFlow Hub is in the training part. You also can, usually you have a own problem if you want to train a model, but if you want to train a model from scratch, it will take a lot of time and an expensive GPU with an expensive GPU. So TensorFlow Hub provide you a choice to stand on using some pitching the model and transfer those feature extraction to your own personal tasks. You have TensorFlow dataset. We can easily reuse the model by transfer learning and tackle your own problem. With a few lines of code, you can retrain with your own data. You can also connect the training pipeline through TensorFlow Extend. And except providing the model, Tensorflow Hub also provide like a complete ecosystem for you to deploying your model in production, whether in server-side, browser, mobile apps. For example, you can deploy model through TensorFlow.js like the previous talk from Kenny. You can also, you can import TensorFlow.js in local module environment or in browser. Also, you can use TensorFlow to deploy your model on mobile and embedded system. And recently, they also provide some Arduino related framework to deploy model on, some more smaller devices and embedded system. In TensorFlow Hub, you can also discover some like ready-to-use model for core edge TPU devices for like IoT. Then the TensorFlow core edge device is an efficient and fast accelerator for deploying machine learning model. If you are interested on that part, you can learn more about this platform from Code.ai. Here's the main page of TensorFlow Hub. Like now, TensorFlow Hub provide more than 1,000 models available with documentation, code snippet, and for some of them, there are also simple demos that you can try interactively. This model can be easily found by searching or exploring the TensorFlow Hub repository. Many TensorFlow Hub models also have like interactive collab or Jupyter Notebook provided directly to the model page, which let you pair with the model with code example right from your browser. And this all hosted on Google infrastructure, so you don't need to do any installation or environment setup, and then you can try on the model easily on your browser. And let's take a look about a couple of examples and see how it can help for solving your problem. Here's some mobile lab. You can see from the website, you can have the JavaScript format or different format of it. Before showing about the code demo, I want to like have a brief intro about like transfer learning. Usually we have like traditional ML, we do have an isolated single task learning. Knowledge is not like we train that or we just start the learning from scratch with one data set. But with transfer learning, we can transfer the knowledge from maybe data sets 1 to another data set 2. We can use the previous pre-trained model as a feature extractor, and then we replace like the later part of the model, like we trim the later part of the model and then replace by some pseudo classifier. It can be logistic regression, SVM, or other kind of classification model. And then to retrain it, like we can frozen the early part of the model, the feature extraction part, and then just retrain to train the classifier part of it. Like in the past, you may need like server width and with a bunch of expensive GPU to train a convolutional neural network, like Inception or the Westlet kind of model. But now, if you collaborate with the transfer learning method, you can just retrain it on your laptop or desktop easily without GPU even. Then we can go through about the collab demo. Firstly, you need to install the TensorFlow Hub. The first example I will show you is about style transfer. Here, let's take a look how TensorFlow Hub can do some artistic style transfer that can work on arbitrary painting style using generative model. So let's say you have an image of yellow lavender. And so here, and you would like to imagine in it the style of your favorite painter, maybe this one. And then you can find a transfer model on TensorFlow Hub. You get the link from the TensorFlow Hub webpage, and then you store it as a variable, and then you import the TensorFlow Hub, and then you do hub.load the URL, and then you can simply just load the image to you in Python code, and then you can run the inference and generate the image. Last part is convert the tensor to image, computation. Let's go for about example. Euro style transfer. Yeah, you can open the link for the slide in the bottom part of it, tensorflow.organization.org tutorial generative style transfer. I will also put the slide in the, I will also put the link of the slide in the last slide. Yeah, so don't worry about it. When you go to the TensorFlow, like the example pages, you can see that you can run it on Google Colab or download the Jupyter book or clone it from the GitHub repository. Also, you can see it from TensorFlow Hub model. You can see the description of the model. You can copy the URL here and read Python, and you can also download it directly. And they also provide documentation, like how can you use the model in Python. You load the image and the target style, and then you can convert to do some pre-processings, and then you can do resizings of the image and then loading the model. Finally, you just run the inference sentence, and then you got the stylized image. Okay. Yeah. In this example, firstly, they do some of the utility function, how to convert the tensor to image, and downloading the image from internet. You can, when you open the Colab link, you can go to this, go to this website, and then you can see all the detail. Firstly, you import TensorFlow and import some utility function and everything image library and to build some utility function. And then you can download image from the internet. You can replace the URL by any image from the internet, download it to the Jupyter notebook. And the second variable is getting the style reference image. And here is also some visualization of utility function. Yeah, we just don't go into detail about those of them. And then, this is the core part of TensorFlow Hub. You just need to import it and then do few lines of code. You can do the inference directly. Import TensorFlow Hub, import the model by the URL, copy from the web page, and then you can run the inference directly by call the model, and you can convert it to the target style. And go back to the link, you can see that except the model for Python, they also provide some TensorFlow-like version. You can deploy the model on mobile phone or mobile phone, Android phone or other thing. They also provide different accuracy or input shape like 256 or INX or FP16. After you try on the code, you can apply the style of the image to the DOM. And another example is about test classification. We will take a look at this, how to do with test classification for your own tasks. So for example, you can import the model like what we previously do. Back to firstly you import the model and then you encode it as a keras layer, and then you can build up a sequential model and add the embedding layer as the first part of the model. And then you can put whatever sentence or natural language into the model. And then you connect with some simple logic, fully connected neural network to do the classification. And this is almost like using the normal TensorFlow API to do the model build up, compile the model, and also do the training as normal. Here you can do the import easily to do embedding instead of training the word embedding from scratch. Usually you don't have enough data set for training up an embedding, or also it took a lot of time to train an embedding. So you also can fine tune. If you don't want to fine tune the embedding model, you can disable the trainable too. equal to false kind of thing. If you want to like tuning the embedding, you can turn it off like true. Yeah, you can. Yeah, okay. Test specification model. Firstly, you import the Tensorflow Hub and install Tensorflow Hub, import all those kind of things. And then in this Colab, they provide example like how you do a IMDb dataset classification. You download the training data from the Dataflow dataset module directly, and then you trim it like 60% training and the remaining part as a testing dataset. And then you build up a iterator for iterating the batch of the dataset. And then you start build up the model. Like, yeah, for test, we cannot, which is a categorical data, we cannot put into like numerical model computation. So we need a embedding for like to convert the test message categorical data to numerical data. And then we can feed into some numerical model to do classification or do some machine learning tasks. And yeah, it's basically like using Tensorflow Keras to do the model building and sequential model, using the embedding layer, building a fully connected layer with adaptation function and tunable. Tunable parameter would be 4 million, but 4,000, so 40 million something. Yeah, it's all tunable if you set when you import when you encode as a Keras layer, if you set to tunable equal to, it will be tunable. You can train it to not tunable in order to reduce the training time. If you just want to like training with like 800 parameter, it will quicker significantly. And you compile the model with some optimizer, loss function, and get some matrix. And then you can feed the data set into the model and start the training on it and get a pretty decent result from it. Okay. And I'm going to talk about what's used in TensorFlow Hub. So first, as model collection on TensorFlow Hub sets go, Google improved the search and discovery feature on TensorFlow Hub to make you easier for you to find the model that you need. So you can filter the model by type, like vision, text, video, or audio. And then you also can filter by the model format. For example, you want to deploy your model in TensorFlow JS or TF-Lite or Coral, you can select the filter option here. And then you can also use this filter to specifically find models that are fine-tunable on your own data sets. Mainly it's the feature extractor. Yeah, and then probably just like previously stated that they provide expanded support for TF format. You can easily find out some model from TensorFlow that support TensorFlow Lite or TensorFlow.js. Then you can easily download the model and deploy on the production easily. And yeah, as a community, like more and more like company are putting their latest research into TensorFlow Hub. Here is some of the example like from DeepMind, Google, Microsoft, NVIDIA, and the number of model is going like quicker. And yeah, I will go through some problem domain you can find out in the TensorFlow Hub. You can find out let's go to the web page of TensorFlow Hub. You can find out different kind of like area like text, image, video, audio, and then you can depend on your own tasks or problem to filter out those things. For example, text, you can find out classification. you may able to do like positive, negative classification, sentiment classification, or you want to do question answering model, you can get the embedding model to train for your customized task. Or you're interested to generating some tests, you can using the generation model. Oh yeah, question. And for the image, you have quite a lot of things like augmentation, classification, depth estimation, classifier, generator again, or object detector, or the pose estimation part of it. Video have like action recognition, text generation. For audio, they also provide embedding like feature extraction kind of model for your own tasks. Yeah. Here's some sample. Yeah, here is the example code of import the BERT model. Like you just import the link and then you can find out to encode the text message you have. So check. Or the object detection is a quite common problem. You can just easily use the model by just few line of code import the model. Using mobile net for classification, you can import the model directly, selection, get the link, and then get the models. Reaching for your own classification tasks. Maybe classify the flower or different kind of thing. I want to go for some other resources from Google. Yeah. In the past, we usually find out those models from maybe the Tensorflow model repository or the website paper with code. But now we can just easily use the Tensorflow to find out store model. And yeah, and if you want to try deploy, after you're doing the transfer learning, you want to deploy your model on your Android devices, kind of thing, you can go to a website called Colab to find out some Tensorflow resources. They provide some tutorial about like how you deploy pre-train the model on embedded Android devices or others. Yeah, I mean, this is the end of my presentation. Yeah, any question about it?